Functions can be in different shapes, but they all have some common key features. So in this video, we're going to go through some of the key features that you can use to describe the lines of a function. On this slide, we can see we have the domain, range, the x-intercept, and the y-intercept. The domain is all possible x values that satisfies the function. So you're only looking at the x coordinates or the x-axis. The range are all the possible y values found on the graph. And the x-intercept is where it crosses the x-axis, and the y-intercept is where the graph crosses the y-axis. So we're going to find all four of these on each of these two graphs. So for the first one, on the one on the left, let's do the domain. So the domain here, I'm looking at all my x values. So if I look at the 6 here, this is an x value, and then go to -6 over here, I can see that the line, if I were to draw a vertical line, it hits every part of the x-axis in between, but you'll notice that there's arrowheads on each end. That means it continues this direction and it continues in this direction. So it keeps going to positive infinity to negative infinity. So there's a couple ways you can write the domain. You could say all real numbers. You could say from negative infinity to positive infinity. So if I were to do it like this, parentheses, negative infinity to positive infinity, that would mean all real numbers. Now the range is talking about my y value, so the height. Since this continues to go up high and it continues to go lower to infinity, I can also say this would also be all real numbers. Or if I want to do negative infinity to positive infinity, I could also do that. So for all linear lines that are diagonal, the range and the domain are always going to be all real numbers. Now the x-intercept and the y-intercept. So the x-intercept. The x-intercept is where it crosses the x-axis, and it crosses the x-axis here. So I could put it as an ordered pair, which would be 2, 0. And then the y-intercept, in this example, where's it cross the y-axis? Crosses at -2. So this would be when x is 0, y is -2. The example on the right, we have a quadratic. It's a parabola shaped. So we're going to identify the domain. So the domain here, it continues to go to the right and it goes to the left. I know the arrowhead points upward, but you'll notice that this keeps going out on a diagonal and this keeps going out on a diagonal. That means I could keep drawing I can draw vertical lines and crosses the x-axis, but you'll notice that this line continues to go up and it goes out. So the domain here would be all real. So for quadratics, so parabola shaped, the domain is always going to be all real numbers, unless if there's restrictions based on a word problem. The range. The range now does have a limit. I'm going to erase the lines that I have here. You can see that there's a limit. It doesn't go below this line. So I would say y has to be greater than or equal to, because it can equal this point, and the lowest y value is at -4. So it has to be greater than or equal to -4. Now the x and y intercept, the x-intercept, where is it across the x-axis? We can see that it crosses the x-axis in two places. So we would say x would be, so we could say -1, 0, and we could say 3, 0. Those would be my two x-intercepts. And then the y-axis, or the y-intercept, where's it cross the y-axis? It crosses here at -3, so this would be 0, -3. Other key features of functions would be when is it positive, which means when is the x values, it's the x values when the graph is above the x-axis. It's negative when the x values, the x values when the graph is below the x-axis. Increasing and decreasing, increasing when it's going up from left to right, decreasing is when it goes down from left to right. So let's do when is it positive. So when is it positive? When is it above the x-axis? So I'm going to look at the x-intercept here. The x-intercept's at 2. So when x is greater than 2, when it's greater than 2, it's above the x-axis. Negative, when is it below the x-axis? Well, if it's above when it's greater than 2, that means when x is less than 2, it's negative. It's below the x-axis. The increasing and decreasing part, when is it increasing and when is it decreasing? Well, this one, if I go from left to right, it's always increasing. So I'm just going to write always increasing. You could also say it's increasing for all values of x. That would also work. Next example, there's no decreasing, so I'm not going to worry about that one for that one. Our parabola shape. When is it positive? So when is it above the x-axis? Well, it's in two places, this place and this place. So when x is less than -1 and when x is greater than 3, it's positive. That means it's above the x-axis. And when is it negative? It's negative in this part. So that's when x is less than 3 but greater than -1. And then the increasing and decreasing parts. From this point, this is decreasing. When does it decrease? Here's where I'm going to look at my axis of symmetry. The axis of symmetry cuts this in half, the parabola in half, and it cuts the parabola in half when x is at 1. So it's decreasing when x is less than 1, and it's increasing, and it's increasing over here. So right here it's increasing. So it's increasing when x is greater than 1. And our final key features is dealing with the end behavior. So what's happening at the end of the line on each end. So we're going to be looking at the arrowheads. So one way to think about it is here when x is increasing, what's my y doing? My y increases over here. And over here, x is decreasing. And what is my y doing? My y is going down, so that's also decreasing. So we would say as x increases, y increases. As x decreases, y decreases. So that's one way you can write that. Another way you can say as x approaches -infinity, y approaches -infinity. As x approaches +infinity, y approaches positive infinity. So it's up to you which terminology you want to use, whether it's an increase, decrease, or negative infinity, positive infinity. Next one over here, you'll notice that my arrowheads are both pointing up. So here, if x is increasing, my y increases. And as my x decreases, my y increases. So if we were to write these, we could say it as x decreases, y increases. And as x increases, y increases. Or you can use the positive and negative infinity, which would mean as x approaches negative infinity, y approaches positive infinity, and as x approaches positive infinity, y approaches positive infinity. Now you have to make sure you write both statements because there are two sides of the line. You have one going to the right and one going to the left. So those are the key features, the main key features of the functions.